Question 18. The masses in kilograms of patients who attended a clinic on a certain day were recorded as follows. Part A. Starting with the class 35 to 39, make a frequency distribution table for the data. First of all, it is very important to peruse through the question so that you make a table which is inclusive of everything. So according to this question 18, we are supposed to get the mean, we are supposed to get the mean and the median. So our table should be inclusive of everything that is required to get the mean from the formula of mean and to get the median from the formula of the median, so that in the questions to follow you will not have to draw another table. So the masses you've been given have not been arranged, but now that you've been told to arrange starting with 35 to 39, we have a hint that the class width in this case is 5. So we shall start with the least class, the smallest class, which is 35 to 39. So we write, so we call it mass. The first class is 35 to 39. Because the class width is 5, it therefore follows that the next class will be 40 to 44, so that it has the same class width as the one given. Then we shall have 45 to 49, then 50 to 54, then 55 to 59, 60 to 64, 65 to 69, 70 to 74, and finally 75 to 79. You may note that we've gone up to 79 because the largest value in the masses scattered in this array is 79. So if we have our masses arranged from 35 to 79, it has captured the whole masses that is given in this case. And this arrangement we got from the hint that was given from the class which was given as 35 to 39. So after getting the mass, we can get the frequency. Frequency measures the number of times an item occurs. So in this case, if we have 35 to 39, we will count all the items that fall within that class of 35 to 39. Then that becomes the frequency of that class. So let's start with the lowest class, 35 to 39. From the scatter figure, from the scatter array, 35 to 39, we have only two values fitting that range. So we write frequency as 2. 40 to 44, we have only 4 values falling in that class, so we write 4 as the frequency. 45 to 49, there are very many, so we can count 45 to 49. We have 1, 2, 3, 4, 5, 5, 6, 7, 8. So 45 to 49, we have 8 falling in that class. So frequency is 8. 50 to 54, also quite a number. 50 to 54, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 50 to 54, we have 9 items. So we write frequency as 9. 55 to 59, we again count from the array table. 55 to 59, we count, we have 59, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 55 to 59, we have 11 items. So the frequency is 11. Then we have 50 to 59, 60 to 64. We again count 60 to 64. We count as 1, 2, 3, 4, 5, 6, 7. So 60 to 64, we have 7. So we write frequency as 7. 65 to 69, we have 5. So we write 5. 70 to 74, we have only 3. And 75 to 79, we have 1. So since our question, we are going to get mean and we're also going to get the median, it is important to include in this table cumulative frequency that will help us to get the median. So in cumulative frequency, we start with the first frequency, which is 2. Then we add as we move downwards. So the next one will be 2 plus 4, which is 6. 6 plus 8, which is 14. 14 plus 9, 23. 23 plus 11, 34. 34 plus 7, 41. 41 plus 5, 46. 46 plus 3, 49. And 49 plus 1 is 50. Likewise, because we are going to get the mean of the data, it is important to work with the midpoint, not just the masses in class as indicated in this table. So we can have our midpoint, and we call it x. To get the midpoint, you get the lower class boundary plus the upper class boundary divided by 2. So for the first midpoint, we have 35 plus 39 divided by 2, which is 37. The second midpoint, 40 plus 44 divided by 2 is 42. The third midpoint is 45 plus 49 divided by 2, which is 47. The fourth midpoint, 50 plus 54 divided by 2, which is 52. The fifth midpoint, 55 plus 59 divided by 2 gives us 57. The fifth next midpoint, 60 plus 64 divided by 2, we have 62. Then 65 plus 69 divided by 2, we get 67. Then 49 plus 3 divided by 2, 74 plus 70 divided by 2, we have 72. Then 79 plus 75 divided by 2 gives us 77. Because you're going to get mean, and we know the formula of mean as sigma fx over sigma f, it is important also to include in the table fx. Fx is the product of frequency times the midpoint. So for the first one, we have 37 times 2, which is 74. The second fx is 42 times 4, which is 168. Then we have 376, 468, 627, 434, 335, 216, then 77. Then from this table, the sum of f is called sigma f. So in the column of f, we add all the values and call it sigma f. That means we add 2 plus 4 plus 9 plus 8 plus 11 plus 7 plus 5 plus 3 plus 1, which gives a total of 50. So the sum of frequency is equal to 50. Then we also get sigma fx, which measures the sum of frequency times midpoint. So we add all the values. So our sigma fx, if we add all the values, will give us 2775. Then once you're through with the table, we can now move to the individual question. So we start with question 18b, part 1. So it's important to note that for the table, we shall get bonus, 2 bonus for correct filling of the values inside the table. So in this case, if the values are correct, then you shall get B1 and B1. Question 18b, part 1. Calculate the mean mass. In statistics, mean of a given set of data is given by the formula mean is equal to sigma fx over sigma f, where sigma fx stands for the sum of the column of fx and sigma f stands for the sum of the column of frequency. So because we have all this data in the table, we can just substitute and call sigma fx is equal to 2775 and sigma f is equal to 50. This means that the mean is equal to 2775 divided by 50, which is equal to 55.5 kilograms. It is also important to write the value because the mean is always of a given value. It can be length, it can be volume, it can be anything. So if you don't write the value, you will miss 1 mark for accuracy. So because you are dealing with the masses in kilograms, our mean must also be in kilogram, and therefore it is called the mean mass. So if you write 55.5, it is correct, but it is not accurate. So if we write 55.5 kilograms, the correct mean. So for calculating mean, we shall get M1 for the formula, M1 for substitution, and A1 for the correct value.